This video is an add-on of my previous kinematic video on how to solve kinematic graph questions. Now, if the question asks, how do you find the speed of the car at time t equal to 2? Now, assuming you find the gradient. Okay, so I'm just going to find the gradient first. Okay, you can see that t equal to 2 is here, where the gradient is actually constant over this stretch. Okay, so you can use equation of the line and gradient to solve. So what is the gradient of the car at this of the graph at this point? First, mark out the coordinate that you want to use so that you don't make mistakes. 640 here is 0, 13. If you don't do this step, sometimes you could just be confused or you could be distracted, or you just make careless mistakes. Don't. So 40 minus 13 over 6 minus 0. You will get 27 over 6. Why is the answer so ugly? Okay, still can reduce a bit. Divide by 3, so it's 9 over 2. Not so bad, 4.5. So the gradient is 4.5. Now, get the equation of the line. How to get the equation of the line? Y equal to 9 over 2x plus c. This thing you have already learned under graph, equation of line, right? Then you sub in a point. Let's sub the one with the 0, the 0, 13. So sub y equal 13, x equal 0. So y equal to, this thing is 0 plus c. No, sorry, y is 13. So 13 equals c. C equal 13. So your equation of the graph is y equal to 9 over 2x plus 13. Okay. Now you want to know when t equal to 2, sub x equal 2, because that's the x-axis. So y equal to 9 over 2 times 2 plus 13. 9 plus 13, and you will get 22. Your speed is 22, and it makes sense? Yes, it makes sense. So you'll be around here. So when t equal to 2, your speed is 22. Now, this method will take slightly longer because you need to find the gradient. You also need to find the equation of the line. Then you sub in. So it's about 3 steps in total. Okay, but if you are a physics student and you're comfortable with what I'm going to say next, I would recommend use what I'm going to say next. Okay, so what I'm going to say soon after this is going to be the easier and faster method if you can understand it. But if you don't, this is the method you should use. Okay, so let me erase everything. Okay, don't need gradient. Yes, I still need the gradient actually. Still need the gradient because usually the first part of the question, they will usually ask you to find the acceleration of the car at t equal to 2, t equal to 3 at a stretch. So let's just say we found the gradient. It's 4.5 meter per second square. Now what is acceleration? If you take physics, I want to challenge you what is 4.5. What is the unit meaning? 4.5 per second square. Okay, I want to give you some insight on this. It actually means 4.5 meter per second, which is speed per second. It means how fast your speed is changing per second. Which means to say, if your acceleration is this, that means your speed is increasing by 4.5 meters per second every second. So let's take a look here. Where is the starting point? It's 13. And how long would have gone? 2 seconds. So 2 seconds, you times 2, which is 9. That means 9 meters per second. That means the speed must have increased by 9 meters per second, up from an original value of 13. So it's 13 plus 9, which will give you 22 meters per second, which is the same answer as your previous answers. But in this case, you do not have to find the equation of the line. You don't have to sub in values. It's just simply understanding what it means by acceleration. If this works for you, go ahead. If it doesn't and you cannot understand at all, and usually it means you don't take physics, use the earlier method.